When a problem says that you need to factor it, it means you need to figure out what got multiplied together in order to get that for your polynomial. When it says solve, it means that we're going to take those factors and figure out what all the x's equal. So the first step of factoring, since it says we should factor it, besides making sure that the equation equals 0, which it does, is we need to divide each of those terms by the GCF. The biggest number we can divide them all by is 5. And since the first number is a negative, we're going to make them all negative 5s. If you ever have a negative in the front, you'll always divide by a negative GCF. And now we divide by the letters, and the most we can divide all of them by is x to the third. So we'll divide all of those also by x to the third. So we write the GCF out front. So here's the negative 5x to the third, and we write the leftovers next to it inside parentheses. So negative 5 divided by negative 5 is positive 1, and 5 minus 3 is 2. So we have 1x to the second. Next, negative 15 divided by negative 5 is positive 3, and 4 minus 3 is 1, or just x. And then positive 20 divided by negative 5 is negative 4, and that x to the third and that x to the third cancel out. So we recopy the blue part, because that's one of the factors. And now we try to factor the green part. We have 3 terms, and there's 2 factors that got multiplied together to get that. So I'm going to write 2 sets of parentheses for the 2 factors and figure out what goes inside. We're looking for the factors of 4 that subtract to get positive 3. If we do 4 minus 1, that will work. 4 minus 1 is 3, and when you multiply it's negative 4. So if it just said to factor, we'd be done because we have the factors, but it said to solve, so now we need to set each of these equal to 0, each of the factors. So we'll write down that negative 5x to the third equals 0 and solve it. And you guys know that when you have the parentheses, when you set them equal to 0, it just flips the sign on the inside. So one of the answers is negative 4. The other answer is positive 1. And when we do the work to solve negative 5x to the third equals 0, what ends up happening, if you remember, is that x is just going to equal 0. Because if we divide 0 by negative 5, it's 0, and the cube root of 0 is 0. It has to be 0, 0, 0, 0. So the 3 answers are x equals 0, x equals negative 4, and x equals 1. Number 2 asks us to use synthetic substitution to evaluate, which means we're going to get one number for our answer. We're going to evaluate that for x equals 3. So when you see synthetic substitution, you automatically should be thinking of making a little box out here. And since this is what x equals, that's what goes in the box. No need to flip the sign because it's already out of the parentheses. And now we take the coefficients from the polynomial. We have 1 in front, and we have x to the third, x to the second, x to the first, and then no x. So it means we don't have any skips. So we'll take the 1, the negative 3, the positive 4, and the negative 5, and we will do synthetic. So we drop the 1, and we start multiplying. 3 times 1 is 3. Negative 3 plus 3 is 0. 3 times 0 is 0. 4 plus 0 is 4. And 3 times 4 is 12. And negative 5 plus 12 is 7. So since all we're trying to do is evaluate, the remainder is our answer. So the answer here is 7. Number 3, we have to talk about the degree, whether or not it's even or odd, and we have to talk about the leading coefficient. So I'm going to put arrows on this graph, and I noticed that both of the arrows point down. So since they point the same direction, the direction has to do with the degree. And when they point the same direction, then the degree is an even number. If they were to point opposite directions, then that would mean the degree was odd. And that's a really good way of remembering it. Opposite arrows would be odd degree. And the degree has to do with the direction, if they're the same or opposite. The leading coefficient has to do with whether or not your arrows open up or down. And these arrows clearly open down, and so that means that the leading coefficient is negative. If the leading coefficient was positive, it would open up. If the leading coefficient is negative, it opens down. Number 4 says to find all of the roots. So not just the real ones, but we want to find all of them. So if you were to look at a graph and zoom out, you would see that there are 2 real roots. But that doesn't account for all the roots, because we know by the fundamental theorem of algebra that we need to have 4 answers here, because that exponent's of 4. So if you found the real roots on the calculator, you can do synthetic substitution and keep factoring from there, or you can factor this problem the way I showed you in lesson 6, example 2b, which is, I noticed that x to the 4th is a perfect square, and so is 625. So I'm going to take those square roots, and since the middle term dropped out, it means that we have 1 plus sign and 1 minus sign. It means that they canceled each other out. So what's the square root of x to the 4th? X to the 2nd and x to the 2nd, because 2 plus 2 is 4. What's the square root of 625? 25. So I'll put 25 in both spots. That way, positive 25 times negative 25 is negative 625, and when you add them up, it gives you that 0 in the middle. So this all equals 0, but we still have 2 factors. We're not done factoring it. We know there's supposed to be 4. So this set of parentheses needs to be broken into 2, and this set of parentheses needs to be broken into 2, if possible. The other way to think about solving this from here on out is, since they are x squared and we can square root to find our answers, is we can just immediately set each of these equal to 0. So we'll set the first equal to 0, and we'll set the second one equal to 0. And now all we have to do is solve for x. So to solve for x in the first set of parentheses, did you see what I did there? I just set this equal to 0, and I set this equal to 0. And now we're solving. So on the first one, we have to minus 25 from both sides. And we have x squared equals 0 minus 25 is negative 25. Now we just need to square root both sides to get the answer. So it's plus or minus. The square root of 25 is 5, and the square root of a negative is I. So there's 2 of the answers, 2 of the imaginary answers. And now we'll solve the other one for the other 2 answers. So we'll have x squared equals positive 25. This time when we square root, we'll just get plus or minus 5. It won't be imaginary because that 25 was positive. And so these 2 answers are real, and these 2 answers are imaginary, and that takes care of all 4 answers. One more thing, it's acceptable to write your answers like that, but I also would accept if you wrote x equals 5, x equals negative 5, x equals 5i, and x equals negative 5i. You'll see it written either way. To write a polynomial with the given zeros, it means that we have to take these zeros, turn them into factors, and then we'll multiply those factors together. So there's 3 of those, so we're going to have 3 factors, And remember, when we go from the zeros to the factors, we have to flip the signs. So it won't be x minus 1, it's going to be x plus 1. It will be x plus 5. And the last factor will be x minus 1/2 because it started off as positive 1/2. Now we can pick whichever two we want to start with, and we will multiply them together. So I'm going to go ahead and start with these two. I'm going to FOIL those two together. When I do that, I will get x squared plus 5x plus 1x, and then 1 times 5 is 5, so plus 5. I'll combine like terms, and it will equal x squared plus 6x plus 5. Now I have to take this and multiply it by the x minus 1/2. And I'm going to actually write that in front because we normally put the shorter one in front. So you can choose to do foil or box. And this is a 2x3, so I'm going to go ahead and make a 2x3 box for this. If you wanted to foil it from right here, that's fine. That's what you'd be multiplying. But in the meantime, I'll put x squared, positive 6x, positive 5, x, and negative 1/2 down there. So x times x squared is x to the third. X times 6x is 6x squared. And x times 5 is 5x. And negative 1/2 times x squared is negative 1/2, or if you're choosing to use decimals, it'd be negative 0.5x squared. Negative 1/2 times 6 would be negative 3x, and negative 1/2 times 5 is negative 5/2, or negative 2.5. Last, we combine all the like terms. So we have x to the third first. 6 minus 0.5 is 5.5, or 5.5, x squared. Then we combine the x's. So 5x minus 3x is 2x. And last we have the minus 2.5. And it's okay with me if you leave your answers with decimals or fractions. If you used fractions, then that number would be 11/2, and that number would be negative 5/2. For number 6, the leading coefficient is the very first number, which is a negative 5. The degree is the highest exponent, which is a 4. So the degree is 4. And the end behavior is which way the arrows point. So do they point the same way, or do they point opposite ways? Well, I remember the little trick. If the degree is odd, then the arrows point opposite. So do we have an odd degree? Nope, our degree is even. So that means that the arrows point the same way. And now we just have to figure out if they both point up or if they both point down. Will they both be like that, or will they both be like that? So now we turn to that leading coefficient. Since that leading coefficient is negative, it means that both the arrows point down. So that's the end behavior. And that's all you need to write for this question. The fundamental theorem of algebra tells us that the number of zeros is the degree. So we just look at the highest exponent, and there are 5 total zeros. So are they all real? Are they all imaginary? Are some of them real and some of them imaginary? What you need to do is type that equation into y equals on your calculator and look at the graph. And when you do, you will see something that looks like, I forget how it starts out, but I know it only crosses the x-axis one time. That means that one of the zeros is real, which means the remaining 4 have to be imaginary. Number 8, you do need a graphing calculator for, because you're going to type it into y equals, and we're going to look for these key features that you have to plot in order for me to grade you correctly. So first we're going to look for the real zeros. So where does it cross the x-axis? Well, when I look at the graph, it looks like it crosses the x-axis around -2, around -1, and around +2. It might not be exact, but those are good ballparks. Next, we need the y-intercept. So where does it cross the y? And when I look on the graph and I press trace, because the whole thing fits right in the viewing window, it looks like it goes across the y right around -4. The local max and min, it's where it changes direction. So when it comes up, and don't draw this, but when it comes up from this 0 to the one right next to it, does it go way up high and then turn around and come back down? Does it come up that far? That's what I'm trying to figure out. When you look at your graph, you'll notice it doesn't go up very far. It doesn't even go 2 spaces up. So I'm going to put that dot right around 1. It does not go up very high. Then we need to do the same thing for in between the next 2 zeros. Does it dip way low, or does it just barely go further than 4? And it looks like it goes down to about -6. So that's the local min. And now we just need the end behavior. And if you look at your graph, it starts by increasing, and then it turns. So now we're playing connect the dots. Goes down through the 0, goes down through the y-intercept, down to that local minimum, and then back up through that last 0. So if you do not plot those particular dots, you will not get full credit on the test. That's all you do. You type it in, and then you find all those key features and plot them. This last problem, not only do we get to solve by factoring, we get to state the multiplicity of each root. So, number 1 rule when we start factoring, does the equation equal 0? Yep, it does. All right, do we have a GCF? If so, what is it? Well, it looks like this can all be divided by, first of all, a negative number, because that leading coefficient's negative. And it looks like 3 will go into all of those. And the most x's we can divide them all by is x to the 3rd, because that's the most x's any one term has. So let's write that GCF, -3x to the 3rd, and let's write the leftovers next to it. So -3 divided by -3 is 1. 5 minus 3 is x to the 2nd. Next we have +6 divided by -3, and that's -2. And 4 minus 3 is 1, or x to the 1st. And then last, 72 divided by -3 is -24. And those x to the 3rds cancel out. So we're going to recopy the blue factor out front. And we need to find the 2 factors that got multiplied together to get that green part. So what we need to do is find the factors of 24 that subtract to give us -2. So it's not 1 and 24, it's not 2 and 12, it's not 3 and 8, but it is 4 and 6. We need it to be -2, so it means the 6 needs to be negative and the 4 needs to be positive. Now we set each of these equal to 0, and if you remember from before, the one in front is always going to equal 0, so we have x equals 0. We'll flip the signs, so we'll get +6, we will get -4, and now we just have to state the multiplicity. See how this was x to the 3rd? It means that really it was 0 times 0 times 0. So the multiplicity is 3. We only had one answer, which was +6, so that's multiplicity 1, and we only had one answer of -4, so that's also multiplicity 1. That way, 3 plus 1 is a total of 5, and there were 5 real roots here.